Now that we've talked about all the different components of a grouped frequency distribution, let's create one. I grabbed the data from above and put it over here, hoping to make it a little bit simpler to work with. Now we can recreate the table that's given in the examples, or we can create our own. Let's work through this as if we didn't know that the other frequency distribution table existed. So the first thing I'm going to do with my data is find the smallest and the largest numbers in the data set. And in looking through here, the smallest number I see is 83, and the largest number that I see is 308. We want to make 5 classes. I'm going to go with the class route instead of the width route. So let's suppose we want 5 classes. To find the class width, we would take the maximum minus the minimum divided by the number of classes. And if I try this on my calculator, 308 minus 83 is 225 divided by 5 will give me 45. Now here's the problem though. If I pick 45 for my class width, I'm going to go through these steps so you can see what happens. Because this turns out to be an exact whole number, I'm going to actually end up with 308 not having a class to go to. Watch. We'll start with 83. I'm going to go through the motion of creating my classes, and then I'm going to have to backtrack, so bear with me. We're going to see what happens. 83 plus 45 will give me 128. Add 45 again, 173. Add 45 again, 218. Add 45, 263. Okay, that's supposed to be 5 classes. These are all the lower class limits that I have. So lower limits. To find the upper, I'm going to look at my next class, 128, and I'm going to go 1 less. And then for this one, 262 plus 45, check it out, 307. So I have 5 classes here, but 308 does not belong to any of them. That's a problem. That's what happens if your calculation for the class width turns out to be a whole number like this one does with 45. So backing up, I cannot use these because I leave out a number. I'm not allowed to leave out a number. So we need to round up to the next highest number. Now 46 will work, and 46 is a great number. It's a little bit hard to calculate and to work with, which is why I think in the previous example that we had, they used a class width of 50. 50 is a little bit easier to manage when you're adding to the class limits to get that next class limit. But we have a calculator, we can do this. Let's create a slightly different frequency distribution than the one that we saw previously. We're going to do it a little bit differently, again, reinforcing that you have a little bit of freedom when you're creating these tables. You could use 46, or you could use a bigger number for the width. You have some choices. So we're going to use 46 for our width. I'll start at 83 just like before. We could also start at 80. The risk with starting with 80 is 46 won't be big enough. So that's something else we have to think about. If we move our smallest number down, we may not capture the highest numbers in only 5 classes. Don't be afraid to readjust and to change things. Try not to be set in your ways when you're creating these tables. Like I said, there's a lot of freedom here. The biggest things that we have to remember is we can't have the classes overlap. We can't have any gaps in our classes. We have to make sure that every single data value is included, and we need our classes to be equal in width. Those are the 4 main rules for creating these grouped frequency distributions. So let's start with 83. I'll get my calculator out. 83 plus 46 will give me 129. Plus 46 gives me 175. Plus 46 is 221. And one more, plus 46 is 267. To get the upper limits, and we'll move these over into the table shortly. to get the upper limits, I go one less than my next lower class limit. So 128, 174, 220, 266. And then to get the last one, we add that class width. 266 plus 46, 312. And these are my class limits. So I'm going to drop these class limits right here in my frequency table. Then we need the frequencies. So I'm going to go through first and start making a tally. Now, unfortunately, this means that my data set and my frequency table being in the same frame on the video is going to be a little tough, but we're going to work through it. So when I'm doing tallies for data, I like to go in an order to make sure that I don't miss anything, and I cross them out again to make sure I don't miss anything. 107 will fit in that first class, so over here I'm just going to have scratch work for tallies. 143, 100, 206, 167, 139, and we can just keep going through. And when I get to 5, I just put a line through it because that means I can count in 5s instead of counting individual lines. It makes it a little easier when we group them by 5s. And we're going to go through the entire table, counting the values and putting them in the places where they go. So if you've hung along this far, pause the video and try this on your own. See if you can finish out the table and tallying in the different spots for our different classes. And then when you resume, I'll have all the tallies done, and then we'll talk about the frequencies. All right. Now hopefully by this time you were able to tally up your data values into each of the different groups. If I'm counting my tallies to turn them into frequencies, 5, 10, 11, 12, 13, 14 for the first class, 5, 10, 15, 21 for the second, 10 for the third, 3 for the fourth, and 2 for the fifth. Now, because my classes are different from what we had previously, I'll flip the page so you can take a look. Here is the frequency distribution that we were using to identify boundaries, limits, width, and midpoints. And we can see here 11, 24, 10, 3, 2. We have different values in the first classes, and that's all because we're not using the same class limits. And that's okay. So the first 2 classes have different numbers in them. We're shifting things around. We have different class values, which means we have a different frequency distribution. But this gives us a grouped frequency distribution. Now the tally over here, this is really just scratch work. It's not part of our table. It's just a way that we can use to create our table. In follow-up lessons, we will look at creating these frequency distributions using technology. And also one more example of creating a grouped frequency distribution and a relative frequency distribution, just so that you can compare them. Before I do that, however, I know it's not in our notes here, but I want to create a cumulative frequency distribution, just so that you can see the difference between them. We'll have almost the same setup in our table, except this time under time, which is in seconds, we're not going to use the same classes that we have here. We're going to use the lower limit of the next class, and we'll say less than 129. So how many values are less than 129? There are 14 of them because of that very first class. I'm going to do one more thing just to make it a little bit neater. Let's move this up here so that we're parallel. And then the next class we would say less than 175. And this time we don't put 21, we add 21 plus 14. So this is coming from the 2 classes that are below 175. Remember, this is cumulative, so we're adding our previous value to the current value. So then doing it again, less than 221. We have 35 plus 10 now would give us 45. So we're adding 35 plus 10, the previous value, plus the value in the corresponding grouped frequency distribution. Less than 267. Add 3 to that. And then the last one, less than, we've got 312 here at the end, so we'd have 313 as our last one, which should mean we've got all of them. I am missing one, actually. No, I'm not. 48. I had a problem adding. Yeah, 45 plus 3 is 48. 48 plus 2 is 50. Yeah, I have 50. Now let's double check. If I look over here at the data, I have 5 rows and 10 columns. 5 times 10 is 50. So I know I have 50 total values. And in a cumulative frequency distribution, this last value will always be the total number of data values. Now, each one of these types of graphs has a purpose for visualizing the data. And we will look at, in the next section, how to take these tables and turn them into very specific types of graphs that also help us to visualize the data in a different way. So we do need these types of distributions to create certain kinds of tables in the upcoming sections. But until then, our next example, we'll look at creating another group frequency distribution. This time we're going to do it for presidential inauguration ages and a relative frequency distribution on that same data.